The last topic for this chapter, substitution reactions and elimination reactions as competing reactions. A lot of you will find this topic very confusing, but I hope by the end of this chapter, following the guidelines, you will have some sense on under which condition which reaction will dominate. So, for both substitution or elimination reactions, we have two starting materials. One is an alkyl halide. The other one is a base, or we can also call it nucleophiles. We have two roots here. The H and X can be removed to give an alkene double bond. That's the beta elimination. While the X can be replaced by Y, that's a nucleophilic substitution reaction. So these two reactions actually compete with each other, and we will see how to determine which one will take place first. So let's take a look at this secondary alkyl halide. Suppose this is the molecule that we want to work on. It's an alkyl halide. And the nucleophile, or the base we have, is ethoxide. If elimination takes place, let's say E2 elimination. E2 elimination, a beta hydrogen will be removed along with the halogen, the leaving group. The beta hydrogen will be removed by the base. Okay, so here is the root. Alkoxide as a base can remove the proton on the beta carbon, so the carbon-carbon double bond forms and the Br leaves. And this takes place by the E2 mechanism. Suppose alkoxide can also serve as the nucleophile. If we want a substitution reaction, what needs to happen is alkoxide, now serving as the nucleophile, must attack on the carbon atom where bromine is attached to, the alpha carbon, right? So here is the root for SN2 mechanism. Alkoxide has to attack from the backside of the of the leaving group. So by looking at these two routes, you see which one is easier? Of course, the E2, right? Because the hydrogen, beta hydrogen, is more outside of the reaction center. It's more open to be removed. While SN2, you have to get into the heart of the reaction center, the alpha carbon, in order to replace the bromide. Okay? So, as a result, what I can say is the characteristic reaction of an alkyl halide with Lewis bases is elimination. Okay, the characteristic reaction is elimination. And the substitution occurs only under certain circumstances. And we have talked about these circumstances, right? One is we need good nucleophiles, right? Good nucleophiles. And the second, we need less crowded carbon bearing the leaving group. that means primary carbon or a methyl halide, right? Okay, so keep that in mind. So the structure of the alkyl halides will have a major effect on which reaction will dominate, as well as the basicity of the anion and the size. All right, so for primary alkyl halides, generally speaking, SN2 is greater than E2, generally speaking, all right? E2 takes place when strong base is around. There will be no unimolecular reaction involved. Examples of strong bases, many of you asked me about this as well. Two examples, alkoxides ions and amides. Okay, so we could have methoxides, ethoxides, T-butoxides. Okay, all of this, they are conjugate base of alcohols. They are examples of strong bases. Next, we will look at tertiary alkyl halides. Tertiary alkyl halides will have unimolecular reaction, E1 or SN1. But one thing I do want to mention here is if you have strong bases, the reaction will still undergo E2. Okay? So strong bases E2. And SN1, the solvolysis reaction, will take place when the solvent serves as a nucleophile. And we've learned only two cases: water as the solvent and the nucleophiles, or an alcohol, especially methanol, is used as solvent and nucleophile at the same time. Okay, so solvolysis is SN1. Other than these two special cases, all the rest of the tertiary alkyl halides will undergo E1 mechanism. Secondary alkyl halides, they could undergo any mechanism depending on what you have. Again, E2 with strong base. This is true for all three types of alkyl halides. E2 with strong bases. SN2 with good nucleophiles, and you've seen at least 3 good nucleophiles as examples. It could undergo E1 or SN1 when the carbocation intermediate can be stabilized. Here, what I'm referring to is allylic or benzylic carbocation may be formed. In that case, it could be unimolecular reaction. Okay? So, these are some criteria. And I hope you will do the problems on the problem set posted on Blackboard to see if you can apply these rules to each specific situation. And we can talk about more reactions in class.